Well, I appreciate being invited here, and I had the luxury of listening to all the talks today, so I kind of looked at my presentation and maybe made some changes as I'm going along. But I do want to approach this more as a philosophical presentation in a sense. I don't have many slides or anything like that. I started working on standard reference diets back in the 80s, kind of proposing them for crustacea. And after working with John Castell and Doug Conklin, didn't get anywhere, but we were looking at the work that had been done by AIN and all that, and we just couldn't get people interested in it. And I hope that's one of the, we're going to have one of those problems here, I think, in the future. But I think we've got a lot of people here, a lot more in terms of helping one another to make that come to fruition. Then I did some work on a what I would call a defined reference diet for macrobrachium, which is a freshwater shrimp, the larval stages. It's 11 larval stages, and I completely replaced Artemia. In fact, it was better than Artemia. Then I started talking to Dr. Watts about that, and then we started talking about, a standard reference diet that might be working with zebrafish. So we've been working together probably since about 2000 on reference diets for zebrafish. I'm going to start this presentation off in a little bit differently because I'm the last speaker, so that I know that we can engender some discussion. So I'm going to give you some of my biases in a sense, and then that can hopefully, like I say, engender some discussion. Is there a need for special life stage defined standard reference diets? I'm going to be emphatic. Yes. Do we need to know all the nutritional requirements of zebrafish to produce exceptional standard reference diets? No. Do potential standard reference diets for zebrafish exist? Yes. Are they really essential? Again, my opinion, yes. So I'm going to go into a few things here. Some of it's going to be repetitious in the sense of I'm the last speaker, and a lot of people have covered all these things, but I'll try to talk specifically about life stages and what we know from some of the traditional fish nutrition or the fish nutrition that dealt with aquaculture organisms. So the critical need here is to manage the nutritional physiology of the different life stages. I look at them as distinct physiological packages in a sense. And in order to, we have to understand the different physiology of these life stages to provide greater confidence, comparative value, and efficient progress in biomedical research. Okay, people have shown this before, life cycle stages of zebrafish, and as you can see, I'm concentrating on 3 parts there: life history, life stages, larval, juvenile, adult. In some cases, we've heard from people that are using exclusively formulated diets, commercially available diets for the larval stages, or combination of live food and formulated diets, then moving into formulated diets specifically for juvenile culture and then on to adult culture. Some people using combinations of formulated diets. So you've all seen that. Oh, sorry. Now, just to show you a relationship here, a growth-age relationship, I think when we look at growth is a fundamental physiological process. It's simple here to see you're moving from larva to adult, that there are changes in the growth rates as it relates to age. And I'm trying to demonstrate that on the left side with length, but it also is true with weight. So we've also seen research that was done many years ago where dietary protein source influences body size and the composition of juvenile zebrafish. So most of this is related to protein deposition. That's what growth is all about. So looking at dietary protein requirements, and a lot of this information comes from aquaculture. And I've kind of generalized here. We're looking at, again, different stages, first feeding larvae to broodstock, and you can see how changes in protein requirements, and again, this is a range because we're looking at probably omnivores, herbivores, carnivores, and you can see how things change, and a lot of it has to do, and a lot of it is shown in terms of growth rate. your first feeding larvae are your fastest growing. A lot of the protein is being used for deposition. Some of that protein is being used as an energy source. So, and then you go down into the fingerlings and you get a reduced amount of protein that is in the diet, broodstock going back up, and that is related to moving into a reproductive stage along with the requirements for lipid. Dr. Hardy talked about all the knowledge that we have about zebrafish nutritional requirements. It's basically nothing. And he put zebrafish down at the bottom of that, what do you call it, the triangle pyramid. And you can see that it's true. I mean, there's really no information on nutritional requirements of zebrafish. And you compare it to trout, where we're moving into sustainable type feeds, where all the nutritional requirements are known. Something that I found that was published in 2016 gives us a good idea that this research that was done, although I have some problems with using fish meal as an exclusive protein source to determine protein requirements, but be that as it may, it comes in probably at the level that I showed you in the previous slide in terms of requirements for juveniles. So what I'm trying to say here is that the existing nutritional information that has been generated for other species of fish, I think it has application as a foundation that we can use to develop a defined diet. So again, the support for foundational application of existing knowledge, that's in relationship to my answer to my question, I should say, about whether we can have these defined standard research diets without knowing anything specifically about the nutritional requirements of zebrafish. So nutritional requirements change during the stages of life cycle. I can tell you that this does happen. It's obvious from some of the work that has been shown here today. How to meet those requirements. And again, these are things that were mentioned by various people in their presentations: physical, size, shape, form, whether you're using inert or live food, consumption and palatability, whether the food is chemically attractive, whether it is palatable, and nutrient sources. Is it coming from live food or is it coming from formulated diets? Those are how the requirements are going to be met. You've got to have the right size and shape. You've got to get them interested in it. It's got to be palatable, and it's got to have the proper nutrients. Okay, here's an experiment that was done in Dr. Watt's lab. This was done back in, I think, about 2003. This was trying to illustrate to people of all the variety of diets that were being used, that some of the problems that you were confronted with. You've got zebrafish that are 28 days post-fertilization, had been previously fed a live food, rotifers. You have 5 commercially available diets at that time, and you had 2 experimental laboratory diets that were kind of based upon the diet that I had used with freshwater prawn, freshwater shrimp. And so we wanted to take a look at those compared to these 5 commercially available diets. They were fed ad libitum and for 9 weeks. A lot of data here. You can see the 2 experimental diets, A and B, have been highlighted. And you can see some of the other diets that had been used in the past. I think we've moved farther ahead. There are a lot of other diets that are being used that are much better. They're not listed here, but that's not the point. The point is, if you take a look at weights for females throughout the diets, you have, after 9 weeks, you're dealing with 68 milligrams to 279 milligrams. For males, 72 to 181 milligrams. If you take a look at the experimental diets, you'll see experimental diet A had the largest in terms of average weight, males. Experimental B had the largest average weight for females. So the experimental diets are working very well, okay? You're getting very, very good growth rates. That may not be what you want, but in this case, it's saying that, you know, what you have developed here is equivalent with what is available in these commercially available diets that are undefined. Okay. I got it. So how is that control achieved? in terms of, let's say, protein quality as it relates to developmental stage. And, oh, 1 minute, there should be another one before that. Okay, how do those commercial diets differ? Obviously, if they were flakes or pellets, they differed in terms of shape and size, and therefore had an effect on consumption. Energy, nutrient content, the protein content in those diets varied from 31 to 60%, and the lipid from 5 to 34%. So again, the differences that you're seeing, I think, are related to nutrient content, but I think there's a lot of other things. You can even say the microbiome that has been created by these differences in protein and lipid in the diet certainly had an effect ultimately on the growth of these fish. The energy content, the nutrient source, quality itself, how good are they? Are they carrying any kind of toxicants or things like that? And the nutrient availability. Once it is consumed, how well is it digested, given the complement of enzymes that are available in that particular life stage of the zebrafish, and how well are they assimilated? So all of these influence physiological processes, and when I talk about physiological processes, I'm talking about distinct physiological packages that are associated with the different life stages. So my conclusion is nutritional control is essential. Now, how is that control achieved? Well, just to give you an example of just the protein source for the different developmental stages and the quality. You have to have a relatively available source. That source has to be consistent in terms of its composition. I'd like to have at least 2 different sources. It has to be very highly digestible. You've got to have that balanced amino acid profile. And it can't be subject to vagaries in nutrient composition, something that was talked about over and over again in previous presentations here today. Okay. Again, this information comes from a lot of published information of aquaculture species, but again, I think it has direct application to the development of a defined standard reference diet for zebrafish. Take a look at larval fish. Phospholipids, very, very important. Now you might say, don't they synthesize phospholipids? Yes, they do. But apparently they don't synthesize them at a rate that is sufficient to meet their needs because of their physiological state, because of how fast they're growing. We saw mentioned today a lot, long chain omega-3 or N3 polyunsaturated fatty acids, very, very important in early larval culture, particularly for marine fish. High protein. I tried to demonstrate that in that relationship between growth and age. Obviously, larvae are putting down a lot as a % of their body weight as they grow, and that is all due to protein deposition. Also, lipid energy sources. Again, we talked about carbohydrate a little bit, and we see that a lot of species of fish do not handle carbohydrates very well, and a lot of that has to do with the proper enzymes for efficient digestibility. If you move to the juvenile adult, again, phospholipids seem to be something that are required. You can call it as a supplement almost, because we know, again, that this particular life stage also synthesizes phospholipids, but apparently not at a sufficient rate. Also, again, predominant lipid energy sources in the diet. And if we move to the brooder, we're talking about now high lipid, high protein diets. We often talk about protein energy ratios and what might be the best or optimum protein energy ratio to have in the diet. Your N3 long chain polyunsaturated fatty acids also become very, very important, particularly in terms of the production of eggs. Vitamin C requirements increase, vitamin E requirements increase, B6, peroxidine also increase. We also need, and I forgot to put it, but somebody mentioned it today, carotenoids in the diet. Make sure the carotenoids are there, particularly canthaxanthin or canthaxanthin, I should say, is primarily the one, or astaxanthin. So you can see the differences, and a lot of it has to do, again, with where they are in development and that they are distinct physiological packages. I thought I was going to come up here and be the only one that didn't have the problem. Okay, so steps toward standardized diets, standardized what I call reference diets for aquatic biomedical research models. And again, I think we can get around having to develop a diet that we can use specifically to try to increase our knowledge of nutritional requirements. That should continue, but I think we can jump over that step based upon all the information that has been provided to us through aquaculture research. So use that existing knowledge to develop that standard reference diet for the key developmental stages. And I see this already, limit live feeds as much as possible. I'm one of those people that think that we have to move away from live feeds and start feeding as soon as possible. Now, I run into problems too, because I can think of a larval diet, and you're saying, I'm kind of promoting the idea that you have to have a lot of lip in the diet. Well, think about producing the small size feed that they need that has a lot of lipid. So there's manufacturing problems here too that we have to consider. Provide the formulated diets through a commercial manufacturer for testing. And I would think, again, as I listen to everyone, again, the idea here is to kind of engender some discussion, and I may be biased, but I think we should try to develop a diet specifically for the juvenile stage and see how that works first among the people who want to try it. And they can go ahead with their feeding management practices, whatever they want to do, but this is the reference diet we want you to look at, and you can compare it in terms of what you're doing now, whether it has to do with a one diet, a combination of diets, a live and a formulated diet, and then establish, based upon that, hopefully, the fundamental acceptance and use of standard reference diets by the scientific community. I couldn't do it about 30 years ago. I hope that we can do it, because I think it's essential for the kind of progress that we're going to have to need. This is a very unique, I learned more today about how unique this particular organism is as a biomedical model. It's just great to look at it. So here, I'll give you just one more thing to think about. When I said something to the effect that I think that a standard reference diet exists already. This is something that's being used in Steve's lab. And again, you can take a look at some of the things. The first three, obviously, are protein sources. Why are they chosen? They're chosen because they don't change in terms of their composition. They were chosen because they're mostly protein. They were chosen because they're highly digestible. All the things that you would want to need. And then you've got some carbohydrate sources in there, wheat starch and dextrin, your oils, your lipids. You can see that right there it's about 6% with the safflower oil and the menhaden, which is a combination of your N6, N3 fatty acids. Alpha cellulose is, well, it's not it's an insoluble source of fiber. Diatomaceous earth is just that filler. Soy lecithin, that's your phospholipid. Alginate is your binder. You've got your, what we talked about before, your vitamin and mineral mixes and things, and canthaxanthin being your pigment source. So basically, something like this, and this is something that has gone through multiple generations, something like this, I think we can look at as a potential foundation for a standard reference diet in terms of our advocacy for that. And I would say that instead of trying to develop diets for the three different life stages that I've outlined, maybe go with the juveniles and see what happens there, and let people stay with their particular feeding practices to start with, and see how this diet performs, and if we can get people interested in it. I'm going to stop there, and hopefully I kind of engendered some discussion about my biases that I had before I came and the ones that I developed while I was here.
Sure. So I imagine a lot of the points that Dr. Zebrafish brought up will be subjects of discussion and then the longer discussion. Does anyone have maybe one question now on anything specific?
Yes.
I thought you showed data. You said you kept animals, the fish, on ad libitum diets for 9 weeks.
Mm-hmm.
And we heard earlier today someone said keeping the food in the water all constantly 24/7 was a bad thing.
Mm-hmm.
You couldn't do that long term. So how did you get around that, or is that, or am I misunderstanding something? about how.
I wasn't advocating that. The question is about feeding them for 9 weeks ad libitum, and what other people were saying is that's being something detrimental, right? Is that what you're saying?
Hard to maintain because it was
Well-
dirty for the water, dirty for the
Mhm.
tank or whatnot.
Do you
Is
want
that
to?
something you were able to get around with in your methodology, or?
Ad libitum at that point in time was primarily defined by feeding a unit of food and allowing them to clean up as much as they can within a defined period of time. That was defined as ad libitum at that point in time. We wouldn't define that as ad libitum now. So that's what he's referring to.
Yeah.
He's not referring to after 24/7.
That's
No. Okay, no.
So it's what gets cleaned up in a uniform amount of time. We don't feed that way anymore.
Remember that was a 2000. Actually, the work was probably done in 2002 and published in 2003. So we're talking like 15 years ago.
We call that parent satiation. Parent satiation. Street feeding.
So we have a 15-minute break scheduled, but we're just a tad behind. And so maybe a 9-minute break. So start at 3:50.
So why is DIA?
Let's thank the speakers again.
Okay, thank you.